With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello, so question is saying that in the following reaction sequence, we have to find out the major product B, right? So that means we have to find out this one, right? So let's start this. So actually we have a reactant, that is, you can see there is a benzene ring over here, right? So this is our benzene ring, right? And this is our NH2 group, right? And there is a methyl group at 4th position with respect to this NH2 group, right? So now this reactant is treated with, you can say this is acetic anhydride, right? So this is our acetic anhydride. The structure of acetic anhydride will be look like this. You can see it. This is our CH3, right? So this is our carbonyl group, right? And it is connected with oxygen. Along with this is our CO and CH3, right? So this is our acetic anhydride, right? So now you can see here, this part can becomes a leaving group, right? So because this is a good leaving group, because this is resonance stabilized, right? So now you can see there is a lone pair over here, right, on the nitrogen, right? So there is a lone pair on the nitrogen, right? So this lone pair will attack on this electrophilic carbon, right? So because of this negative oxygen, this carbon becomes electrophilic, right? So this carbon becomes partial positive and here it becomes partial negative, right? So now you can see this will attack on here and the reaction proceed in this way. So you can see this is our benzene ring, right? So this is our benzene ring at 4th position. There is a methyl group with respect to this nitrogen, right? So this is 1, 2, 3, 4, right? And here, so you can see this, the reaction will proceed like this. Since nitrogen gave its lone pair, that means it acquires positive charge, right? Over here, and it will look like this. So this bond will sit like this, right? So it becomes negative here, and this CH3, right? So that means this is 3 I'm writing here, right? And this OCOCH3 I'm writing here, right? So this is OCO, right? So this is OCOCH3, right? OCOCH3, right? So now you can see here, this negative charge when come back, right? So this negative charge when come back, so here this cannot be leave, right? So this has to leave, right? So this oxygen has to leave, because after leaving this group, so this is resonance stabilized and it becomes very good leaving group, right? That means, and this cannot be leave, right? So because if this leave, that means reaction will proceed in backward direction, right? So again we are getting the same product, right? So but we have to find out the product, that means we have to carry out the reaction in forward direction. That means we have only one option, that we cannot leave this, we cannot leave this, so we have only one option. So that means we have to leave this, right? So that means you can see here, so the bond will go like this, right? And in this way we can say this, we have a product A like this, right? So now you can say there is a positive charge over it, so the electronegativity of nitrogen becomes very more, right, as compared to original nitrogen, right? So since nitrogen is also electronegative and this positive charge also increases its electronegativity, that's why it's attract its shared pair of electron and release a proton from here, right? That means the product will be look like this, right? You can see here, this is our benzene ring, right? So this is our benzene ring, right? So this is benzene ring and this is nitrogen, and now we are left only with one proton here, that one hydrogen, right? So this is NH, right? So this is C. Now this becomes C double bond O, right? So this becomes C double bond O, right? And this is CH3, right? This is CH3, right? And at 4th position there is a CH3 group also, right? At 4th position there is a CH3 group, and from here this acetate leaving group will leave and there is a formation of acetic acid, right? So you can see this is CH3 COO negative, this one, and from here proton will be captured by this acetate ion. So I can write here this will be equals to H positive, right? So this will be equals to H positive, right? So I can write here this is equals to, you can see here, this is equals to CH3 COOH, right? So now we have this product A, right? So this is our product A, right? So but we have to find out the major product B, right? So now if we carry out this product A with the reaction of bromine, that means if we carry out the bromination, right? So if we carry out the bromination here, right? So Br2, that means we have gained acetic acid, that means we have to carry out the bromination here in acetic acid, right? So that is ACOH, right? So I can write here this is CH3 COOH, right? So now you can see here aniline is a very strongly activating group, right? So that means which is ortho and para directing, right? So this is ortho and para directing, and this is also a weakly activating group, because the lone pair on nitrogen will get two sides, right? So that means it can go from carbonyl, or it can go towards the carbonyl and it can go towards the benzene, right? So that means it's, you can say that its activating power decreases, right? So due to this carbonyl group, right? So that means it becomes weakly activating, although it is ortho and para directing, right? So although it is ortho and para directing, and this methyl group is also ortho and para directing, right? So now you can see here, due to the ortho and para directing, this if we carry out the bromination here, that means bromine either will attach here or either will attach here, right? Now you can see here, these two positions are same and these two positions are same, right? So now you can see here, if bromine attach here, that means this is the position of ortho with respect to this group, right? And this is the position of ortho with respect to this group. And now you can see here in the overall structure, para position is blocked, right? So now we are left only with the ortho position, right? So now question arises that where will bromine attach, right? So this one at this position, at this position. Now you can see here, this group will activate the benzene ring through plus M effect or plus R effect, right? So that means this group will activate the benzene ring through plus M effect, that means mesomer effect, or you can say it resonance effect, right? And this group will activate the benzene ring through plus I effect, right? So now we have the relation that always you can see here there is a mesomeric effect, that means there is a participation of this lone pair, right? So that means mesomeric effect will dominate over plus I effect, right? So here the mesomeric effect will dominate over plus I effect. In this way I can say this, the bromine will attach at this position with respect to this, because this is ortho position with respect to this group, right? So now the product will be formed like this, right? So this is our product, right? So you can see here, this is our benzene ring and this is nitrogen here hand, right? So this is NHCOCH3, right? So COCH3, right? And this is our CH3, right? So now you can see para position are blocked, right? So now you can see here, this is the position where bromine will attach, right? So now I can attach bromine here, right? So now you can understand here why bromine does not attach here, because here this is a position, meta position with respect to this group, and this is a ortho position with respect to this group, right? So but we have to prefer the mesomeric effect, right? So and mesomeric effect occur in this group, right? So that means this will dominate over plus I effect and bromine will only attach will here, right? So that means the product will be look like this, right? So now we have to match our options, right? So now we have to match our options. You can see here, so in this is our option A, right? This is our option A and this is option B, right? So this is option C and this is option D, right? So now you can see here, at para position there is a CH3 group, right? So that, but you can see there is a CH2, right? CH2Br, that means this cannot be our answer, right? So this cannot be our answer, right? So now we have a NHCOCH3 group, that means there is a NHCH3 group, this will be group and this is also group, that means this is common in all three options A, B and D, right? So now with respect to this group there is a bromine here, right? So now with respect to this group there is a bromine, right? So that means this will be the our answer, right? This will be the our answer, right? And if you can see option B, that means there is at ortho position, that is COCH3, right? So this cannot be our answer. And in option D, the bromine is at meta position, right? So bromine at meta position with respect to this group, right? So this cannot be our answer, right? So now we are left with the correct option, that is option A, and this will be our correct answer, right? So hope this answered your question. So thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.